Hello students. So today we are starting a new chapter, Kinematics, right? So first you write some general points which we will use in complete chapter of Kinematics, right? So first we are taking the general points which we will use in complete chapter of Kinematics. First thing, in the chapter of Kinematics, scalar quantities are distance, speed, time, right? Distance, speed and time. And the vector quantities are displacement, velocity, acceleration, right? Displacement, velocity and acceleration. Note down this. Second point is magnitude of velocity at any instant is called speed at that instant, right? So note down magnitude of velocity at any instant, magnitude of velocity at any instant is called acceleration at that instant. It's called acceleration at that instant. Therefore, speed means magnitude of velocity vector, and this can also be called as v. And you know that magnitude of a vector is always positive, right? So speed is always positive. It is always positive. Let us take an example. Suppose velocity at any instant is 3 I cap plus 4 j cap meter per second, right? This is velocity. Because velocity is a vector quantity, therefore you can write it in terms of I cap, j cap and k cap. So suppose this is velocity. Then magnitude of this vector, magnitude of v vector, or you can say simply v, it is equal to under root of 3 square plus 4 square, right? It means it is 5 meter per second. So this is the speed. I think point will be clear. Magnitude of velocity at any instant is called speed of the particle at that instant, right? So note down. Now come to the third point. Direction of motion of a particle. Direction of motion of a particle is in the direction of its velocity. Right? It is not in the direction of acceleration. Or from the direction of motion, you cannot determine the direction of acceleration. Are you getting the point? Direction of motion of velocity is in the direction of velocity. It has nothing to do with direction of acceleration. Or from the direction of acceleration, from the direction of motion, you cannot tell me the direction of acceleration. So note down, direction of motion, direction of motion of the particle is in the direction of its velocity. Direction of motion of the particle is in the direction of its velocity. From the direction of motion, note down, from the direction of motion, you cannot determine the direction of acceleration. Let us take one example. Suppose I say that a boy is moving eastwards. What does it mean? It means direction of velocity of boy is eastwards. Right? From this statement, you cannot find the direction of acceleration. Right? So suppose you are given that a boy is moving towards east. It means its velocity is eastwards. And from this statement, you cannot find the direction of acceleration. So note down, example, a boy is moving towards eastwards. A boy is moving towards east. A boy is moving towards east. It means its direction of velocity. Its direction of velocity is eastward. Its direction of velocity is eastward. Full stop. From this statement, you cannot find direction of acceleration. You cannot find direction of acceleration. Right? Now come to the fourth point. A curvy linear path means a path which is not straight line. That is called a curvy linear path. For example, circular motion, parabolic motion, elliptical motion, etc. These are the examples of curvy linear paths. Right? So a curvy linear path means a path which is not straight line. So down. A curvy linear path means a path. A curvy linear path means a path which is not straight line. Means a path which is not straight line. For example, circular path, parabolic path, etc. Right? Circular path, parabolic path, etc. It means like this, like this, like this. These all are curvilinear paths. Now you note down the fifth point. On a curvilinear path, direction of velocity of the particle at any instant is tangential to its path. Right? At curvilinear path, direction of velocity of a particle is tangential to the path. But again, you cannot find direction of acceleration unless some other information is given. Right? So note down direction of velocity on a curvilinear path. Direction of velocity on a curvilinear path is tangential. It's tangential at every point. For direction of acceleration, some other information will be required. Right? You can see a figure. Suppose this is a curvilinear path at this point, and suppose particle is moving along this direction. At this point, velocity is this. This is v1 vector. At this point, velocity is this. This is v2 vector, and so on. Right? Acceleration may have any direction. Acceleration may be like this. V. Acceleration may be like this, etc. Right? So on a tangential path, on a curvilinear path, direction of velocity of the particle at any instant is tangential to the path. And for acceleration, you will require some other information. Right? Now come to the sixth point. At any instant, if velocity vector and acceleration vector has acute angle, then at that instant, speed of particle is increasing. If angle between A vector and B vector is obtuse, it means at this instant, velocity, speed of particle is decreasing. Are you getting the point? If at any instant, acceleration and velocity has acute angle between them, then at this instant, speed of the particle is increasing. If at some instant, acceleration vector and velocity vector is making an obtuse angle, it means at this instant, speed of the particle is decreasing. Right? So note down. At some instant, if angle between velocity vector and acceleration vector, is acute, is acute. Then at this instant, speed of the particle is increasing. If angle is obtuse, then angle of the particle at this instant is decreasing, right? So you can make two figures. Suppose this is velocity and this is acceleration. This time acute angle. Means speed is increasing. If you have the figure like this is velocity vector, this is acceleration vector, and this angle is obtuse. Then it means speed at this instant is right. Now come to the 7th point. In 7th point, I am making a table. In the first column, we will write a statement. In the second column, you have to write down direction of B vector. And in third column, you have to write direction of A vector. Make this table. First statement you write moving upwards with decreasing speed. So in first column, first statement you write moving upwards with decreasing speed. Now you see, a body is moving upwards. It means its velocity is up, right? But its speed is decreasing. I have to give answer only in up and down, right? We have to give answer only in up and down. So body is moving upwards. It means velocity is up. But its speed is decreasing. It means acceleration is opposite direction. Acceleration is acting in opposite direction. So acceleration will be down. Is that clear? If a statement is given that moving is upwards with decreasing speed. Moving upwards means velocity is upwards. But speed is decreasing. It means acceleration is in opposite direction. Next we write lift is descending. With increasing Lift is descending. Descending means it is coming downwards, right? And it is coming downwards means direction of velocity is down, right? So direction of velocity is down and its speed is increasing. It means its acceleration is in the same direction as that of velocity. It means acceleration is also downwards, right? So acceleration is also downwards. Now let us write one more statement. Lift is ascending. With constant speed. Lift is ascending means it is moving upwards, right? It means its direction of velocity is upwards. But it has constant speed in one dimension, right? It has constant speed, so we can say that its acceleration is 0. Right? No doubt. Next you write lift is ascending. With increasing speed. Again, lift is ascending. Ascending means moving upwards, right? So what is the direction of velocity? It is up, and its speed is also increasing. It means acceleration is in the direction of velocity, right? Acceleration is in the direction of velocity, so acceleration is also upwards, right? So it is. So these are the basic points which we will use in complete chapter of kinematics. Distance, speed, time, these are scalars. Displacement, velocity, acceleration, these are vectors. Magnitude of velocity vector at any instant. Magnitude of velocity vector at any instant is called speed. It's called speed, right? Direction of motion means direction of velocity, not the direction of acceleration. Curvilinear path means a path which is not a straight line. Tangent to a curvilinear path is the direction of velocity, right? But it does not give you direction of acceleration. If acute angle between velocity and acceleration, it means speed is increasing. If obtuse angle between velocity and acceleration, it means speed is decreasing, right? And I have given you some statements and the directions of velocity and acceleration in those cases, right? Now let us come to second point, general definitions. Write down general definitions. First, distance and displacement. Let us call distance by d and displacement. It is a vector quantity, therefore write it S. Suppose a particle moves like this. A, B, C. Then ABC total length, that is called distance, right? Distance equal to total length ABC. And AC, this is displacement vector, right? It means S equal to AC vector. And in the chapter of vectors, we have already studied that this S vector is also equal to R final vector minus R initial vector. And if I find the magnitude of S vector or S, then it is simply AC. Right? One more point. Distance is always greater than or equal to displacement. Distance is always greater than equal to S, and when these two are equal, when a particle is moving in a straight line in one direction, right, without changing its direction. So D equal to S when particle moves in a straight line, without changing direction. Right? Now come to the second point. So distance and displacement is simple. Distance is total length and displacement is AC vector or R final vector minus R initial vector. Now come to the second point. Speed. First point of it, as you know, speed is a scalar quantity, right? Hold on. Second point is speed is of two types. One is instantaneous and other is average speed. Right? So note down. Speed is of two types. One is instantaneous. It is denoted like this: V instantaneous or simply V. average. It is denoted like this, V average. Right? So instantaneous speed is V instantaneous or V, and average speed is V. Now come to the third point. Magnitude of velocity at any instant. Right? Magnitude of velocity at any instant is instantaneous speed at that moment. Right? Note down. Magnitude of velocity vector. Magnitude of velocity vector at any instant. Magnitude of velocity vector at any instant is the instantaneous speed at that moment. Is the instantaneous speed at that moment. Therefore, you can write it like this, Vi or simply V. This is magnitude of velocity. And fourth point, average velocity means total distance upon total time. Right? So average speed equal to total distance. Total distance over total time. Rather you can write d over t or total distance upon total time. Right? So average speed is total distance upon total time. Now come to the fourth point. Fifth point. If a particle is moving with constant speed, then its average speed is equal to that constant speed. Right? Suppose a particle is moving with constant speed of 4 meter per second. It means its average speed is also 4 meter per second at any interval of time. Right? So note down. If a particle is moving with constant speed, then its average speed at any interval of time, is equal to that constant value. Right? Sixth point. Again, if the particle is moving with constant speed, then distance equal to, there is a direct formula, distance equal to that constant speed into time. Right? So note down. If particle is moving with constant speed, then distance equal to speed into time, or d equal to v into t. And seventh point, If particle is moving with constant velocity in a straight line, then velocity means speed, displacement means distance, right? Then we do not differentiate between velocity and speed, and distance and displacement, because both are same, right? If the particle is moving with constant velocity in a straight line, then we do not differentiate between velocity and speed, displacement and distance, both are same. So note down, if particle is moving with constant velocity, if particle is moving with constant velocity in a straight line, then velocity and displacement, velocity and speed are same. Velocity and speed are same. Similarly, distance and displacement are also same. Displacement and distance are also same. So in that case, we can directly write B or S equal to V into T, provided velocity vector or speed is constant. Nothing it can say. I think it's very simple. So speed is of two types: instantaneous speed and average speed. Instantaneous speed is magnitude of velocity vector at some instant, and average speed means total distance upon total time. If speed is constant, then average value of distance, average value of speed in any interval of time is equal to that constant speed. Further, if speed is constant, then distance equal to speed into time. If velocity is constant, then we do not differentiate between displacement and distance, speed and velocity, and so on. Right? Now, next come to third point, velocity. First point, it is a vector quantity. So we can write it in terms of I cap, j cap, and k. Right? So velocity is a vector quantity. Now come to the second point. Velocity is again of two types. One is instantaneous velocity and other is average velocity. Right? Note down. Velocity is again of two types. Velocity is again of two types. Instantaneous V instantaneous or V. And average. V average. Right? Now come to the third point. This is very important. Listen it very carefully. Right? This is very important. Listen it very carefully. Suppose a particle starts from here. It starts from here. It means it is initial position vector. Since velocity is a vector quantity, that's why I am using complete things in vector form. Right? So suppose particle starts from here, then this is the initial velocity vector. It is moving like this, and at some time t, particle is here. Further you can say here. At time t. It means it is the position vector of particle at time t. Is that clear? And this is the displacement vector at time t. Right? So first you note down this. Particle starts from here. At time t, particle is there. So this is the displacement vector at time t. Now you see, our initial vector is constant. Because starting point of the particle is fixed. Or you can say starting coordinates of the particle are fixed, right? Because starting point oblique coordinates are fixed. Is it clear? If particle starts from one position, then obviously its initial position vector is fixed. Now, RT vector, you can simply write it like this also. Sometimes you simply write it like R vector. It means it is position vector at time t. Similarly, this can also be written as S vector. Right? Now you see, RT vector or R vector are different at different times, or we can say that these are the functions of time, right? Because the particle is moving, sometimes it may be here, it may be here. So this vector, you can see it is varying. It means it is function of time. So note down, RT vector or R vector. RT vector or R vector is different at different times. Or we can say that it is function of time. Right? One more point. If this R vector is varying, then obviously this X vector will also vary. You see, after some time this R vector may become like this. So S vector will become like this. Therefore, S vector is also function of time. Right? So note down. S vector is also different. S vector is also different at different times. S vector is also different at different times. Therefore, it is also a function of time. Right? So finally we can write that R vector or S vector are functions of time. From the subtraction of vectors, you can also see that S vector is R vector minus R initial vector, right? S vector is R vector minus R initial vector. Note down. But in this relation, R initial vector is constant but vector, right? And R vector or S vector, these are functions of time. I think point will be clear to you. R initial vector is constant vector, is a constant vector, but position vector at any time t or displacement vector at any time t are functions of time. Now come to the fourth point. Fourth point is instantaneous velocity vector or v vector. This is nothing but differentiation of r vector or differentiation of s vector with respect to time. Instantaneous means at some instant, right? Instantaneous means at some instant. Instantaneous means at some instant. Right? So we simply write many times v equal to dr by dt equal to ds upon dt. So just it is differentiation, nothing else. But vector differentiation, right? It is nothing but a vector differentiation. And this is also called, one more point, if we find d by dt of r vector, d by dt of r vector or d by dt of s vector, then it is sometimes also called rate of change of. Means you can write it like this, d by dt. It is also called rate of change of. Rate of change of means, rate means in 1 second, in unit time, right? Rate means in unit time. So d by dt means rate of change of. For example, if I write v vector, then what is its definition? Rate of change of. Rate of change of r vector, or you can write rate of change of S vector. Okay. Now we want to check why these two quantities are equal. You just see, S vector was written as R initial vector, R vector minus R initial vector. Just check the previous figure. Maybe that will be wrong. So S vector is actually R vector minus R initial vector. You just see, this is R initial vector, this is R vector, and this is S vector, right? So S vector is R vector minus R initial vector, but this is a constant vector, a constant vector. Hence, if you differentiate this function ds by dt, it means it is dr by dt minus 0, because differentiation of any constant quantity, whether it is scalar or vector, its differentiation is 0, right? So from here we can see that ds by dt is nothing but dr by dt. Once again I repeat, if a particle is moving, then initial position vector will remain constant, but its position vector at any time t and displacement vector at any time t will vary, or that is a function of time. If we differentiate r vector or s vector, with respect to time, right, then it becomes instantaneous velocity. Instantaneous means at a particular instant. Instantaneous velocity means at a particular instant. Okay. And instantaneous velocity is also called rate of change of r vector or rate of change of s vector. Right? Just note down. So students, as a revision, I am taking few problems of vectors, right? Just as a revision, I am taking a problem vector. It is page 66, question 51. Page 66, question 51. A cross B mod is given. Root 3 mod of A mod of B. And asked is what is mod of A plus B. Right? So magnitude of A cross B is AB sin theta. This is AB sin theta equal to root 3. Mod of A is A, mod of B is B. Sorry, it is root 3 A dot B. A dot B. So it is root 3 A dot B means AB cos theta, right? Now AB cancels with AB. So tan theta you can see that is root 3 sin theta over cos theta, right? It will become sin theta over cos theta. So tan theta will become root 3 or theta will be 60 degrees. Now what is modulus of A plus B? Modulus of A plus B is given by under root of A square plus B square plus twice AB cos of theta. And theta is given 60 degree and cos 60 is root 3 by 2 and 2 and 2 cancels out. So ultimately it will become under root of A square plus B square plus root 3 of AB. I think clear? This was given, this was passed. This means AB sin theta, this means AB cos theta. So from here we have found that theta equal to 60 degree, right? And then you can find A plus B naught. So students, it is enough for today. In the next lecture we will continue general definitions of kinematics, right? So far we have read distance, displacement, instantaneous speed, average speed and instantaneous velocity, right? We are studying instantaneous velocity, right? Thank you.